Okay, so factoring. Factoring, what's going to happen is that we have two options right now. One, if we have two terms. Another one, if we have three terms. Okay? But we always begin with greatest common factor. That's what they have in common. Alright? So we're going to actually concentrate on, for right now, we're going to concentrate on the two terms. We're going to be looking at this part of the little tree map here. Okay? So, moving on, let's look at a couple of examples. Alright, so let's say if we had 2x squared plus 16x, and we were asked to factor. Okay? We were asked to factor. Alright, so what would we do? Well, if we go back to that factor tree on the page, what we would do is that the first step is to do greatest common factor, what they have in common first. So we need to look at the numbers to see if they have anything that, any number that both numbers can be divided into. Right, so we have 2, we got some factors, well, hold on. We got some factors 2, 2, and 1. And then we also have 16. Some factors 16. We got 1, 16, 2, and 8. What else do we have? We got 4 and 4. So if you notice, they're both divisible by 2. Okay, so that's nice. So what we can do now is that we can go ahead and factor that out. Choose green. Green's kind of nice. And we'll put 2 on the outside. And once we put that factor out the 2, we need to put parentheses. X squared. And then, of course, 16 divided by 2, that's going to be 8 right there. So I'm going to have 8x left. Alright? There's no number technically in front of the x squared. There's just an implied 1. That's why you don't see a number there. Alright? But the other part of greatest common factor is that I need to look at my variables also. So let's take a look at my variables. Okay, my variables. X squared and x. Alright, so let's take a look at their multiplication. We have x squared, which that's the same as x times x, and then of course x just equals x. Well, what I can do here is I can go ahead and take an x from both of them. So what's going to be left is I have 2 on the outside because this 2 stays there. And now I'm going to factor out, meaning I'm going to divide from both terms, an x. And then of course when I factor something out I have to put my parentheses. So I put my parentheses there. And then what is left when I take an x from x squared? Well, if we look back down at our multiplication, it is just going to be an x is left. Okay? Now if I take an x away from 8x, well, there's nothing here. Well, it's not 0, it's actually an implied 1. Because if I divide 8x by x, the x's will cancel, and I'm left with an 8. And seeing that there is no more exponents, there is no x squared or x cubed, the numbers can't be divided, there's a 1 here and an 8 here, I am actually going to be done. So this is going to be my answer. 2x times x plus 8. Okay, now let's take a look at something else. Windshield wiper, yay. Okay, so let's take a look at another problem. We have 2x squared. Sorry, 2x squared again. And then let's say I had plus 32. And my question to you was, let's go ahead and see if we can't factor this. Okay, so the first step, again, always, from that factor tree, is going to be greatest common factor. So we have to take a look at our numbers, and then we also have to take a look at our variables. But let's take a look at our numbers first. Okay, so we have 2. 1 times 2 is 2, and that's really the only thing that we can do there. And the factors of 32, let's just go down the list. We'll start off with 1. 1 times 32 divided by 1 is 32. It is even, so 32 divided by 2 is 16. Can't be divided by 3. It can be divided by 4, though. 32 divided by 4 is going to be 8. Right? 8 times 4 is 32. And I do believe that is going to be it. Can't be divided by 5. Can't be divided by 7. And 32 divided by 6 is about 5.3. Okay? So these are going to be my factors. And again, we have the same answer. They're both divisible by 2. So if I factor out a 2, I have x squared plus 1. Oops, I wasn't supposed to do that. We have x squared on the first term, and then when I divide 32 by 2, I get 16. So then I have plus 16, stays positive. Now, in this example, there is something a little bit different. I have an x squared term here because I haven't taken a look at my variables. But the problem is that I don't have an x term here. So I am actually done for this problem because there's an x squared here and there's an x here. If I were to actually do this, I have x squared that is equal to x times x, and then of course there's no x. So technically it's just 1. So there's nothing I can circle. Okay, that doesn't work. So this is going to be my answer. 2 times x squared plus 16. That is how I factor this example. Okay, let's try something a little bit different, because if you remember, part of that factor tree for 2 terms was difference of squares. Alright, so let's do this one, but a little bit different. Let's do the windshield wiper again, get rid of all that stuff. Alright, we'll start off with white. So, I have 2x squared. I'm going to do that one again, but I'm going to change the sign. That's my only difference from the previous problem. I have a negative here now. No, bad calculator. Didn't mean to do that. Sorry. So, first off, nope. Erase. Sorry, getting ahead of myself. Alright, so, my question... I don't know what I did. Hold on. Can I pause? Okay, sorry about that. So, let's take a look at this one. 2x squared minus 16. Question is, can we go ahead and factor this? And, well, first thing we always have to look at, first step, is going to be, what do they have in common? What's the greatest common factor? And, of course, we need to look at the numbers and the variables. So my numbers are here, and then again, just like in the last problem, I just have x squared, I don't have anything here. Alright, so 2 and 16, we know from the previous example, I can factor out a 2. Which leaves me with 8 there, of course. So I have 2 times x squared minus 8. Okay, and of course I can double check this. If I just distribute this back in, I would again get 2x squared minus 16. That's just a quick way to know how you're doing that correctly. I'm going to go ahead and erase that though right now, so we don't get confused. So that's back to our original answer, 2 times x squared minus 8. Now, the second step, since this does have a negative, what we need to look for is, we need to look for, can we do difference of squares? Alright, in difference of squares, there's 2 things that we need. One, we need a negative in there, okay, that minus symbol. And if you see that, that's right here. This is the minus symbol we're talking about. Okay? But the other thing that we need is perfect squares. Nice square rootable numbers. So I'm going to go ahead and write perfect squares. Perfect squares. And the thing is that on this example, in particular, we don't have that. there's a 1 right here, an imaginary 1, and then this is 8. Well, the square root of 1 is nice, right? That's going to be 1. But the square root of 8, that's going to be about 2.8 something. Even simplified, we'll have 2 square root 2. And that's just not going to work for our problem. Okay? So technically, on this one, we are done. When we have 2 times x squared minus 8. This is all we can do. We can't do difference of squares on this one. Okay? So let's go ahead and move on to one that we for sure can do difference of squares. So windshield wiper again. Another example, same thing. 2x squared minus 32. Alright, so again, I'm going to ask you to factor. First step, what is it going to be? Greatest common factor. Of course, what do they have in common? And we've done a couple of these by now. We should know that, well, this is even, this is even. I know I can pull a 2 out. So I'm going to go ahead and kind of skip that factoring step. So what I have left is x squared minus 16. Alright, now the second step is because I still have this x squared here. I still have it here. So I need to see if I can keep factoring to get rid of that. And because I have this negative, I need to check for difference of squares. Okay, difference of squares. Alright, so this one actually is going to work out a whole lot better. Reason being is that there's a 1 here, and we discussed earlier that square root of 1, that's just going to be 1. You can check that on your calculator if you would like. Also, square root of 16, this number right here, this is going to be equal to 4. Okay, so that works out for you. No decimal, no decimal. That's a good thing. So let's go ahead and just move to our formula. If you remember at the beginning of the recording, there was a formula I wrote on there for difference of squares. It was a squared, I'll go ahead and write out a squared minus b squared. That was going to equal to a plus b and then a minus b. Okay, so it helps us when we take these square roots because these are what is going to go here. Okay? So let's go ahead and do that. Alright? So we still have a 2 on the outside. That doesn't go away. So we have 2. We're going to do double parentheses. And then my a. Well, the square root of x squared, that's just going to be x. So I have an x here, an x here. I have a plus and I have a minus. Those don't change. We're always going to have that plus and minus. And then I just need to take the square root of 16, which we know from over here is just going to be 4. And thus, I don't have any x squareds, no exponents larger than 1, because remember there are imaginary exponents here that we have 1, but it's kind of implied, so we don't write them. And this is going to be my answer. Alright, so those are just a couple examples as far as 2 terms go. For factoring, I'll go ahead and do a separate recording for talking about 3 terms and the Mustang method. But those are essentially one example, each of the different ways that you're going to use factoring. Okay? Again, if you have any questions, please feel free to use Edmodo, Twitter, and or email. Okay? Or feel free to stop by for tutoring. Nope. Wrong button.